Welcome and hello. This is a video exercise in HEC RAS. And in this exercise, we're going to be dealing with steady state flow under a bridge. And I'm calling it bridge extension. So what I'm going to use for the problem statement is right here on the screen. Find the maximum flow rate in the main channel without overbank flow for a bridge length of 1,000 feet and then later extend it up to 1,500 feet. The bridge must have a 12-foot wide pier every 250 feet. All right, so I understand that that problem statement doesn't provide all the details we need, but it is a preview of sort of what we're going to be doing coming up in this exercise. All right, let's go ahead and file new and create our project. I'm going to save this in exercises and then project, and then going to go ahead and give the project a title. I'm calling mine exercise 7 and okay. All right, so I'm using US customary units. First, what I want to do is define the geometry. So I'm going to go ahead and click river reach and do a single left click to start the reach and then sketch in the direction of flow and then double click and then go ahead and give that river a reach name and river name. All right, that looks good. Next up is cross sections. So I'm going to use the same cross section I typically do here. Add new cross section. I'm going to start at river station 0 and then type in the coordinates here. Okay, there is the final coordinate. So it goes down from 90 to the overbank of 60 and then the invert of 30 and then back up to 90. The distance downstream is going to be 0 because this is the downstream most cross section. And then Manning's N, I'll just use 0.03 for the main channel. And then the overbank is going to be at station 300 and 700 as I've defined it here and as it shows up here in the preview. All right, that looks good. I'm going to add one more cross section at the top of the reach here. So options, copy the current cross section. I'm just going to say this is 1,000 feet upstream. And the only things I need to do to change this is to say it's 1,000 feet in left overbank, main channel, and right overbank, and then increase the elevation values. So I'm going to say options, adjust elevation, and then I'm going to say 2 feet. So that will be a slope of 0.2% and apply data. All right, so that's taken care of. I'm going to go close, file, save geometry data. Now I'm going to save this with the title 1,000 foot bridge. I know we haven't sketched the bridge in yet. I'm about to do that, but I just wanted to save the file before I forget. So click OK. That's going to be .g01 for the file name. Let's go ahead and I want to add a few more cross sections. The user manual mentions that there should be a couple cross sections downstream of the bridge and upstream as well. So let's just go ahead and go Tools, Cross Section Interpolation within a reach, and then I'm going to just do it every, say, 100 feet. Okay, interpolate cross section, close. Here are my interpolated cross section. That looks good. I'm going to put the bridge at river station 200 or 300 between these two cross sections. So I'm going to remove all the other cross sections. Just as a quick way to doing that, I'll just go to cross section here. Let's start on cross section at river station 100 and delete cross section and yes, and also confirmation, yes. Okay, so I want to keep the cross section at river 200 and 300. So now we're up to 400. You can see here. So options, delete cross section, yes, confirm. Options, delete cross section, yes, confirm. Okay, so that is all the deletions. This image will update in just a moment when I close that. All right, perfect. So I've got my cross sections here. I'm going to go ahead and now sketch the bridge in, which is going to be, if it's an 80-foot wide bridge, then I'll leave 10 feet on each side. So the upstream face of the bridge will be at river station 290, and the downstream face of the bridge will be at river station 210. Hopefully that makes sense. Let's see if I can build that. So click the bridge/culvert button over to the right, and then we're going to select options, add a bridge or culvert. This is going to be at river station 290. Okay. Now what it gave me is the geometry of the terrain of the cross section for upstream bridge and downstream bridge. This is at river station 290. Next, I'm going to click this deck/roadway button. This is where I'm going to actually sketch in the bridge. So let me bring this over here. So the distance downstream is going to be I believe just 10 feet. And then the width of the bridge is 80 feet. So that means 10 feet downstream of the next upstream cross section, which is 300. So 300 and 200. And yeah, I think we're good there. Okay, I'm going to type in some of the coordinates here. So this is facing downstream, looking left to right. So station 0 is going to have a high chord of, let's see, let's make it 94, and then a low chord of 0. And don't worry, I'm going to go ahead and add that low chord a little bit higher for the next station of 100, 94, and 86. And then let's see, 100 from the end would be 900. So I'll say 900, 94. The high chord is always going to be 94, 86. And then finally, the last station will be 94 and 0. Okay, copy that to the downstream side so I don't have to type all the same numbers in twice. And then I'll use a 2-to-1 embankment side slope for both upstream and downstream and click OK. All right, so now we see in the cross-section view of the bridge, it's in place. We still have to add those piers in every, what was it, 250 feet. So with a bridge that's 1,000 feet long, it'll be at 250, 500, and 750. Let's go ahead and add those piers in right now. So I'll click the pier button. And now what we have is a pier number 1. It started me off with a pier automatically, but I can add, copy, and delete piers as I want. All right, so the first one's going to be at River Station 250, both for upstream and downstream end. I said the width of the pier is going to be 12 feet. I believe the problem statement said 12 feet. The elevation, I believe HEC-RAS wants me to put the base elevation first and then the higher elevation. Okay, so I think 60 up to the low chord elevation of 84, or was it 86? Let's go 86 to be safe. So we'll say 60 and 12, 60. The high elevation would be, again, 12 foot wide and 86. Okay, I'll click OK, and that looks good. And just from the preview, it's at River Station, or sorry, cross-section station 250, and then it extends from the overbank up to the bottom of the bridge deck. What I want to do now is add 2 more piers. One will be at 500, cross-section station 500, and cross-section station 750. So pier, I'm going to go ahead and just go left to right so I got the numbering down. This is number 1. I'm going to click copy now. So now I'm on number 2. They're identical at the moment, but I'm going to edit number 2 and then click OK to save. So that's going to be at 500. The other thing I need to change here is the base elevation. So instead of 60, I'll just make it, say, 30. That should be low enough. So instead of 60, it's 30 there. Instead of 60, it's 30 there. And OK. That looks good. One more pier to go. I'm going to make a copy of number 1. That's good. All I need to do now is change 250 to 750 and click OK. Now what we want to do is create a flow, figure out the maximum flow that will go through this channel that doesn't cause any flow in the overbank. So basically what we want to do is figure out what flow rate causes the water surface elevation to be right here at the overbank elevation. Now there may be some fancy ways to do this, but I'm not aware of any at the moment. So what I'm going to do is create a steady state flow profile with a few different flow rates. And my first iteration is going to be rather coarse. The second iteration will be a little bit more fine-tuned. I believe the value is somewhere around 200,000 CFS, but I'm not sure. So let's just go ahead and create a range from 100,000 CFS up to 300,000 CFS with a 50,000 CFS step. All right, so that's my plan. That's where we're going next here. File, save the geometry data. Then we're going to go up to Edit, Steady Flow Data. Now let's set the boundary conditions first. So we'll just use normal depth for downstream, and we'll set it to the channel slope, and OK. Now for profiles, I'm going to set it to 5. 1, 2, 3, 4, 5. And the lowest flow is going to be 100,000 CFS. And then the next profile will be 150,000 CFS, all the way up to 300,000 CFS for profile 5. Okay, that looks good. Let's go File, Save Flow Data. What I'm going to do for the title is I'm going to say 100K-300K underscore 50K. So I know the min, max, and the step just by glancing at the title of the flow file, and click OK. Let's see how that goes. Save flow data. I just did that. and then close. Let's go ahead and run this simulation and see what happens. So I'll click on the running man icon, and it already starts me off with the geometry file and the steady flow file. That's good. All I have to do now is save this plan. So for the title, I'll say the bridge length and then the range of flows that I'm trying for the title of the plan, and same with the short ID, and click compute. All right, so that ran. I'll click close. Now let's go ahead and look at the view cross sections. All right, so this is profile 1 we're looking at right here. So this is probably a good start. I think the flow that we're interested in will be in our range because we also have 3 times this flow, which is the maximum of 300,000 CFS. What I'm going to do is go options and then toggle on the different profiles. So instead of just profile 1, which is 100,000 CFS, I want all 5 profiles. So I'll select all, click OK. And here we have what looks like 150, 200. So it's going to be between 150 and 200. Let me zoom in here. Okay. So yeah, this is 100,000 CFS. That's profile 1. Boom. Profile 2 right here is 150. And then profile 3 is 200,000 CFS. So I think it's safe to say that our answer is going to be between 150 and 200,000 CFS, probably closer to 150. So what I'm going to do is go back, create a new flow file with a smaller range and a smaller step so we can get a more close approximation of what the target flow rate is for our problem statement here using the 1,000 foot long bridge. All right, so edit, steady flow data. Now what I'm going to do is file, save flow data as, and then I'm going to give this the new title of 150K to 180K underscore 10K step. So this is only going to be 4 different flow profiles. I'll click OK. The reason I made a copy is that way I don't have to do the boundary conditions anymore. That's already done. But I will change this. Yes, I understand I'm losing the last record there. Then let me delete these so I can type them back in. I'll start with 150,000 there, all the way up to 180,000 CFS. File, save the flow data, close it. Now I'm going to click on the run once again. This is the same thing as going run steady flow analysis. And it has my same geometry file for the 1,000 foot long bridge. And then the steady flow file is this one I just created. All right, so let's save that plan. And I'm going to just save it with, again, the bridge name and the range of flows, or the bridge length. Same thing here, and compute. All right, that's computed. So let's click close, and then let's look at some results. View, cross section, and then options. I want to see all 4 profiles. So select all. Okay. Now let's zoom in here. And it looks like profile 2, which is 160 CFS, is just perfect. See if I zoom in anymore. Okay, maybe a little bit off, but for the most part, very close. I'm going to say the answer to the 1,000 foot long bridge for our answer of just flow in the main channel with no overtopping is 160,000 CFS. All right, well, that was the first part of this exercise. The second part out of 2 parts is, what if we extended this bridge another 500 feet? So the bridge is now going to be 500 feet longer, a total of 1,500 feet. This lower channel, the main channel, will also extend 500 feet out. So for instance, say there needs to be more conveyance and the bridge needs to be extended, then that's a possible real world situation. Let's go ahead and do it. All right, so I'm going to go ahead and close this. Let's go back to our geometry data. And instead of 1,000 foot long bridge, I'm going to save this geometry data as a 1,500 foot long bridge. So the new title is going to be now 1,500 foot bridge. Okay. Now I need to actually make the changes in the terrain, the cross section soil data itself, as well as the bridge. So cross section. And what I thought would work is if I highlight these values and then set option, adjust station, add a constant, and type 500. And if I do that, it actually adds 500 to all of the station values, not just the ones I highlighted. So there may be another way to do that, but it's no big deal. There's not too many points. I'm just going to retype the first few. So it's at 0, 300, and then 400. So now what we have is, instead of a 200 foot wide base to the main channel, it's now going to be 700 feet from river station 400 up to river station 1100. So what I need to also do is change, see, this to a, that's 300. Okay, I think that's correct. And then apply. Okay, in the view here, let me right click and then full plot. That looks better. Don't worry about these results. I wish I could clear these results. There may be a way to do that as well, but the results were from the previous simulation. What I need to do is make these same changes though for the other three cross sections. This was just the cross section at River Station 1000. So to make that faster, I'll just go ahead and highlight these values here, the 8 station values, Control C to copy, and then let's go up to the other cross section, I guess down to River Station 0, and then highlight all the station values, Control V, and I also need to change this to 1200 and apply data. Okay, let's do that 2 more times. So this is the cross section at River Station 200. Select, paste, 1200, apply data, and then River Station 300. Highlight these, paste the new values in, and the right overbank is at 1200 and apply. Okay, so again, right click, full plot, and then that looks good. All right, we need to make the same changes to the bridge or similar changes. So let's save this geometry data while I remember. Bridge and culvert. Now this looks kind of funny because the bridge just stops at 1,000 feet because that's what the data was originally from the previous file. Let's go ahead and extend that though. So I'm first going to click on this bridge x/roadway button. And what we want to do is just extend this over. So instead of 900, I'm going to make this 1400. And instead of 1000, it'll be 1500. Okay, just like that. So these are the two new values and the two new values. Everything else I'm going to leave the same. Let me click OK and just confirm from the profile or this plot here. And that looks good. Clearly, I need to add a couple more piers. So let's do that. This is pier 1, 2, and 3. Let's add a 4 and 5 at river cross section station 1000 and 1250. So I'll click on pier. I'm going to make a copy of number 3 here. Click copy. That made it number 4. That's good. And then I'll go 1000. Everything else looks good. I'll click OK. And now we need one more pier up on the right overbank. I'm going to copy number 1 here, copy, and then just add a 1 to the stationing for both upstream and downstream, and click OK. All right, so there's my final pier. I think this is all we need to do for the geometry, but what I am going to take a look at this moment is estimate what sort of flow rate or range of flow rates we should first try in our first iteration, first trial, to try to figure out what flow rate would result in a water surface elevation just right here at the overbank elevation. And from before, we had 160,000 CFS, but that was just this area right here. So I don't know, maybe 3 times as large, like 500,000, close to like 500,000 CFS. So what I'm going to do is go from 400,000 CFS to 700,000 CFS as the first trial. We'll see what happens there. All right, so close that file, save the geometry data. Now we want to go edit, steady flow data, and I'm going to do a file, save flow data as, and then the numbers are going to be 400K to 700K with a 100K CFS step. All right. Again, we don't need to touch the boundary conditions. That's all the same, but this will be different flow profile values. 400,000, 500,000, 6, and 7. Okay, file, save flow data. Let's close that. Let's click on the steady flow analysis. Already it has the geometry file that I want. This is the 1,500-foot bridge profile and the steady flow that we just saved and created. All right, file, save the plan. And now I'm going to paste in the title for the plan now, which is the bridge length underscore and then flow range in CFS. So I'll click OK. And then same thing here for the short ID and then click compute. All right, so that ran. Let's go ahead and see what our cross sections look like. View, cross sections. And now we have all 4 profiles showing up again. Yep. And it looks like it's right around 500,000. So profile 2. Yeah, it's just below profile 2, it looks like. So let's see. This is profile 1, that's 400,000 CFS. This is profile 2 of 500,000 CFS, and then 600 and 700. So again, just below 500,000 CFS. What I want to do is one more iteration just to sort of fine tune the range a little bit closer. So it's going to be 400 and 500. Let's do a ceiling of 500 and then maybe something like 450 up to 500. So that would be 6 different profiles. All right, back to our steady flow data and file, save flow data as. So for the range, it's going to be 450 up to 500,000 CFS, and that's with a 10,000 CFS step. So I'll click OK. And then for number of profiles, I'll say 6. You just move this over a little bit and then delete the previous data. All right, the first value is going to be 450,000. The last value is going to be 500,000. 500,000 CFS down to 450,000. All right, file, save flow data. I'm going to close that and then go back to the steady flow analysis. All right, it automatically loaded in the new steady flow file that we just created. That looks good. I'm going to go file and then save this plan again with the bridge length underscore flow range. Okay, same thing with that, and compute. So that looks good. I'm going to close, view cross sections. Okay, so let me zoom in here, and I'm only seeing the first 4 profiles. So let me go options, profiles, select all, since the last one only had 4. And it looks like we are 1, 2, 3, 4 between profiles 4 and 5. Here's profile 4, that's 480,000 CFS. Here's profile 5, that's 490,000 CFS. So if I had to guess, I'd say it's a little closer to profile 5, maybe 487. All right, let's go with 487. I'm not going to continue on this path, but you kind of get the idea of what I'm trying to do here. Perhaps not the fastest or most efficient way to do it, but we're learning HEC-RAS and all of its features nonetheless. All right, that was it for this exercise. We learned how to create a cross-section, add a bridge, modify that bridge, and then run some steady state flow simulations, and then look at some of the results in the cross-section data.